So 2 to the third times 2 to the fourth equals 2 to the x. Okay, so if I take 2 times 2 times 2, because that's what 2 to the third is, right? And then I have 2 times 2 times 2 times 2. How many 2's do I have in total?
7.
There you go. So x is going to equal 7, right? So this is going to be 2 to the 7th power. So if you have the same base, you're going to add your exponents. Okay? All right, on B, we've got 2 to the second power, and we're going to raise it to the third power. So that means I've got 2 to the second times 2 to the second times 2 to the second. Well, we just learned that if we have the same base and we're multiplying, we're going to add the exponents, right? So what's 2 plus 2 plus 2? 2 to the 6th power. Okay? So if you have a power raised to a power, you're going to multiply your exponent. Okay? So if you have a power raised to another power, you're going to multiply the exponents. If you have the same base, you're going to add the exponents. All right? On this last one, if you're dividing, okay, if you're dividing, you've got 6 2's in the top. So 1, 2, 3, 4, 5, and 6. And then you've got 2 2's in the bottom. Well, we know that if you have something in the top and the bottom, and they're the same, they cancel out, right? So how many 2's do I have left over? 4. So the way to do this, really simply, is to take the exponents and subtract them. Subtract exponents. Okay? They have to have the same base, though. That means that if it was 3 to the 6th power divided by 2 to the 2nd power, then it wouldn't work. Okay? All right, so go ahead and take a moment and write these down on your paper. We're going to continue the exponent rules. And hopefully you learned this a couple of years ago. If you didn't, that's okay. I'm going to teach you now. Okay? So on that first one, it's taking 2x and raising it to the third power. Notice how the parentheses are around the entire 2x. Okay, so this is really like saying 2 to the third power and x to the third power. Well, what's 2 to the third power? 8. And x to the third is just x to the third. Okay, so whenever you raise something entirely to the third power, you got to make sure that you're using those parentheses, because this and that are two totally different things. Okay? Same concept over here. If you have something that's in a fraction and you're raising it to a power, you're going to take what's in the top and raise it to that power, and take what's in the bottom and raise it to that power. All right, this is my favorite rule. Anything to the 0 power is going to equal 1. And if you're like, I don't remember that, you can go into your calculator and you can type 2 raised to the 0 power, and that's going to give you 1. Every single time. 1 million raised to the 0 power, 1. Okay? And the last exponent rule that we have is the negative exponent rule. Okay, the negative exponent rule actually tells us to flip the fraction. Okay, and what I mean by that is right here we've got 2 over 1, or you know it as 2, right? But if I were to flip the fraction, that would make it 1/2. And we're raised to the first power, so it's already raised to the first power. Okay? So negative exponent means you're going to flip it over. Questions on these four? Everybody good on this? All right, so let's look at the last slide. Bear with me. You got this. We're almost done. I want you to find the value for each variable. Find the value for each variable that makes the equation true. So if you're rewatching this, you're going to pause the video and try it on your own and then check your answers. But if you're in class right now, y'all are trying that. So hopefully these first two were pretty easy, and that third one was probably the only one that gave you trouble. If not, let's go over it. So 8 to what power gives us 1? Well, we just learned that anything raised to the 0 power is going to give us 1, right? Okay, that should be a quick and easy one. This is also going to be on your SAT. If you haven't taken your SAT yet, or if you haven't taken the ACT, there's a lot of these type questions. So you have to know your power rules, okay? On number 2, if we're multiplying, then that means that we're going to add our exponents, right? Okay, so if it has the same base, we're going to add the exponents. So 4 plus negative 6 is going to give us that b is negative 2. Another way to think about this is if you take 4 9s and put it in the top, and you've got this negative 6 power. So that means that you're going to have 6 9s on the bottom. And for every one that's in the top, you've got one that's in the bottom, you're going to cancel out. How many are left in the bottom? 2, okay? And that negative is representing that it's on the bottom, or it's on the other side of where it should be, okay? This next one, we've got 5 to the negative 3rd power times 2 to the negative 3rd power. So our bases aren't the same, which means we can't add our exponent. Most of you probably sat there and thought, oh, d is going to be negative 6. Nope, that's not true, okay? Because if we plug this into our calculator, we're going to get something else than 10 to the negative 6 power. If we plug this into our calculator, this little expression right here, we're going to get 0.001. Okay? Well, my question to you, what is 1 divided by 10? If I put that in my calculator, it's roughly 0.1. So in order to get from 0.1 to 0.001, I'm going to move the decimal place over 2 more times, right? Which means that I have flipped this, right? I've gone from 10 to 1/10, which means that d is going to be negative, as well as you moved the decimal place over 1, 2, 3 times. So d is actually going to equal negative 3. On this one, it's a lot of calculator work. Best way to do it is to plug in your original expression with what you think the answer is. So if you thought it was negative 6, okay, you would have plugged it in and those decimals would have been different. Okay? All right.